Alright, so now in this last part here, we want to use this data from experiment number 5 to try to figure out what my rate would be given all this information here. Ignore this. This is just... forgot to erase that. Anyway, so I'm just going to plug in my concentration of A for A, my concentration of B for B, my concentration of C for C. Keep A to the first, square B, and square C, and then multiply it by my 2.85 times 10 to the 12th per meter, or I'm sorry, molarity to the fourth and seconds to the first. So here we go. So rate, so 2.85 times 10 to the 12th, big M to the negative fourth, seconds to the negative first, times 3.01. This is right from my table. Big M to the first, 1.00 times 10 to the negative third squared, and then 1.15 times 10 to the negative third, big M squared. I forgot my units here. So when we do this, just plug 2.85 times 10 to the 12th times 3.01 times 10 to the negative third, hit enter, then times, and in parentheses 1.0 times 10 to the negative third squared, hit enter, times 1.15 times 10 to the negative third squared, hit enter. And if we do that, going off of memory here, but I think it was 0.0113. Yeah, that looks consistent with what we have up here. And my units will cancel down to molarity per second, which means every second, once we start here, my molarity is going to decrease by 0.0113, or actually my concentration of my products will increase by this in the very beginning. So that's how we calculate the rate for experiment 5. So to kind of recap, to figure out my exponents, I just looked at my ratios of my concentrations to my ratios of my rates in a set of 2 experiments where only one concentration is changing, the other 2 are kept the same. From that, I can determine using either logs or just kind of intuition to figure out the exponents, how changing my rate affects my, or changing my concentration affects my rate for each of these substances. And then to find K, all I do is rearrange my equation to get K by itself and then plug in data from any one of the runs with the exception of 5 because we didn't know our rate. And then to find the rate, once we know our K, plug in concentrations for the steps that we're looking for, and we're done. We really could do this for a reaction that had dozens of reactants. We would just be here for a very long time, but these are all done the same way. So hopefully this clears things up for those folks that are struggling, or solidifies stuff that for those folks that think they got it. And anyway, good luck tomorrow, and we'll see you then.